Hi, my name is Doug Priestley, and joining me today is Dana Clark with the Nordine Technical Service Department. For today's Lunch and Learn topic, we're going to give you a brief but informative introduction to the 18 SEER condenser product line.
As part of this introduction, we'll talk about the description of the components, the sequence of operation, and some troubleshooting highlights.
If at any time you have a question, just type it into the Ask a Question box on the side of your screen. We will answer the questions at the end of the presentation. Some of the system matchups can achieve 19 SEER. We have 2, 3, 4, and 5-ton condenser capacities. You still have the benefit and reliability of a Samsung compressor. You will also find a variable speed broad ocean condenser fan motor.
Inside the house, you can take advantage of a variable speed broad ocean blower motor. Installers and homeowners will both appreciate the simplicity of being able to use a standard 24-volt heat pump capable thermostat. Service technicians will have the availability of 2-digit LED status codes and diagnostic troubleshooting information. The condensers use R410A refrigerant and have operating temperatures from 50 to 125 degrees. Here's an example of how the model numbers will break down.
The condensers use a Samsung rotary compressor and use 410A refrigerant. The speed of the compressor is determined by the inverter. When troubleshooting the compressor, you'll have to use an ohm meter and test for short, open, or grounded windings. The compressor does not have an internal overload. The voltage control signals from the inverter to the compressor are pulse width modulated. This type of signal cannot be measured with a standard voltmeter.
Since the inverter controls the speed of the compressor, if the inverter fails, it should be replaced. If the fuse on the inverter board fails, do not replace the fuse. You'll have to replace the inverter. Keep in mind that there are no serviceable parts on the inverter. The interface board is the brain of the system and works with a 24-volt AC signal from the thermostat. Based on if the thermostat is providing a Y1 or a Y2 input signal, this determines what speed the compressor will be running at in either heat or cool mode. There are 5 distinct speeds the system will be able to operate at during either mode. The interface control board will display a 2-digit error code in addition to an operational code to help aid in troubleshooting for technicians in the field. The interface board will also control the reversing valve. The valve is still energized in the cooling mode. The voltage will come from the O terminal on the interface board.
The high pressure safety switch is wired in series from the inverter board to the contactor. If this safety switch opens, it will break voltage to the contactor and shut down the condensing unit. The low pressure safety switch is wired into the interface control board. If this switch opens, the inverter will then receive a signal and shut the unit down. Should the low pressure safety switch open, the interface board will display an error code number 19. Should the switch close, the unit will attempt to restart. The condenser has a total of 5 temperature sensors. The first is the outdoor ambient temperature sensor. This is used for defrost control, as well as helping control the system operation during minimum and maximum temperature environments. The minimum operating temperature in the heat mode is 0 degrees Fahrenheit, and the minimum temperature for cooling mode is 50 degrees Fahrenheit. The maximum operating temperature for cooling mode is 125 degrees. The next temperature sensor is the discharge temperature sensor. This is used for compressor override and fault conditions. If the temperature reads 221 degrees Fahrenheit, the unit will shut down and an error code will be displayed.
The next 2 sensors are located on the outdoor coil. Coil sensor number 1 is used for controlling defrost. Coil sensor number 2 is used to control the condenser capacity when the system is in cooling mode. The 5th sensor is the suction line temperature sensor. All 5 sensors are 10K ohm resistors and can be checked using an ohm meter. Each sensor is also color-coded for easy identification. The reversing valve is energized during cooling or during a defrost cycle in heat mode. The valve solenoid receives a 24-volt signal from the interface board. The power line filter prevents electrical noise from leaving the unit. This filter is also paired with the reactor coil to prevent electrical spikes entering or leaving the unit.
Now that we've reviewed the components in the 18 SEER units, let's talk about the sequence of operation. There are 5 stages of operation in either cooling or heating modes. Cooling stages are marked C1 through C5, and heat stages are H1 through H5. When the condenser receives a call, the stage it starts at will be determined by a combination of thermostat input and length of the prior run cycle. For cooling mode, the unit receives a Y1 call from the thermostat to the interface board. The outdoor fan motor will start and run for 1 minute prior to the reversing valve being energized, and then the compressor starts. In most cases, the unit will start at stage C2. With a Y1, Y2 input to the condenser will run on stage C4 for 45 minutes. If the thermostat is still calling after 45 minutes, the system will go into boost mode, stage C5. In heating mode, the condenser receives a Y1 signal from the indoor thermostat. The outdoor fan motor again will start and run for 1 minute prior before the compressor starts. In most cases, the system will start at stage H2. With a Y1, Y2 call from the thermostat, the condenser will stage up to H4 and run for 45 minutes. If the thermostat is still calling after 45 minutes, the unit will go into boost mode, stage H5.
During heat mode operation, when the system is ready for a defrost cycle, it will use the adaptive demand defrost sequence. This means that the frequency of the defrost cycle will be based on system runtime and the outdoor air temperature. The 18 SEER heat pumps can be matched with B6 VMAX air handlers or with any G7 furnace model, provided there is a variable speed blower motor. If an 18 SEER heat pump is going to be paired with a G7 MQ model of furnace, the IQ Drive controller will still be used in addition to outdoor sensor kit part number 920938. Let's also talk a bit about refrigerant charging. To check the charge in cooling mode, you'll want to lower the set point on the thermostat so it calls for Y1 and for Y2. The condenser will start and run at stage C4, which is nominal capacity. C4 will run for 45 minutes. This 45-minute stage time is your opportunity to test your charge level. If you'll be charging in the heat mode, the best practice is to weigh the charge, being sure to account for any additional charge needed for line set lengths greater than 15 feet. You'll also find heat mode charging charts in the install instructions to help get the charge dialed in.
The Technical Service Department also has training material available for the FT4BG units. The literature order number for the training book is 980D0912. We hope you have enjoyed today's introduction to the 18 SEER product. We'll go ahead and start the question and answer period. Thanks for watching. And just a reminder again, if you have any questions, please don't hesitate to type your question in on the lower left-hand side of your screen there and just submit them to us, and we'll try and get them answered for you. One of the first questions we have, Dana, is an outdoor temperature sensor required with a dual fuel thermostat?
An outdoor sensor will be required for dual fuel application with the 18 SEER heat pump. That's with the White Rogers thermostat especially, because they do not include an outdoor sensor individually packaged with that thermostat. So you would need to include that in terms of the overall system installation for a dual fuel application.
And another question here from Nancy with Supply New England. Do we know when the 18 SEER will be available? My understanding is they're going down the line right now. They're waiting on some other testing that has to be complete, and hopefully you'll see them in the next couple of weeks. I would check with your RSM and verify the launch date or ship date with them. Next question, Dana, is there a special motor that we need with the 18 SEER?
A special motor. Well, it needs to be, in terms of the blower motor inside, it would have to be an SEER package motor. Basically a variable speed of V-sheet package, if you will. So it would have to be like a G7TC V model. Basically it has to be that SEER blower package so that you are getting the actual 18 SEER matchup on the efficiency.
Okay, another question is, do we still have to use the W2 output when in defrost? I can answer that. Yes, you will. We need to still tell the indoor unit when the system is in defrost so we can get that supplemental heat during the defrost mode to help temper the air when we are running in defrost. Another question is do I need, is an outdoor temperature sensor located in the outdoor unit?
There is already an outdoor temperature sensor that will be installed at the factory in the condenser. That is not specifically for use in terms of dual fuel application, though, because remember, with the 18 SEER product, part of the whole idea behind the advancement of that 18 SEER product was to be able to use it with standard 24-volt thermostat control circuits and not just specifically with the IQ controller. If you are using an MQ model of furnace, though, you do still have to use the IQ controller thermostat, if you will. You won't be able to use an MQ furnace with a 18 SEER heat pump and a standard 24-volt thermostat. You'd have to use the IQ controller for that.
Next question from John with Anderson Heating. Does the heat pump shut down at 0 degrees, or can you run it at a lower temp? Minimum operating temperature for the heat pump in the heating mode is 0 degrees. You cannot go any lower. That's going to be set by the thermostat there, and also controlled by the different sensors out in the unit itself. In cooling mode with the heat pump, the minimum temperature you can operate the unit at is 50 degrees. And in the highest temperature that the unit will be allowed to run is 125 degrees Fahrenheit. Again, keep those questions coming in. We'll get them answered for you. Question with Tim with Nolan. The additional charge beyond the 15 feet table in the II differs slightly from the usual 0.6, 0.7, 0.8 per ounce beyond 15 feet. Yes, pay attention to the technical specifications, IIs. Charge is slightly a little bit different, so pay attention when you're adding that extra charge to the unit for any line sets over that 15 foot, beyond that 15 feet on that line set. And again, remember to weigh in the charge when you're adding that additional refrigerant, and make sure you use a refrigerant type scale for weighing in that charge. Pedro with Refer Center, any plans for an 18 SEER straight cool? At this time, I'm not aware of it. I'm sure we will. I would check again with your RSM, your sales rep for verification with that, or the product manager on that too. I have not too sure right at this point. Another question from Randy with American Air Systems. What is the capacity range between C1 and C5, and how many speeds does the air handler use? C1 and C5, it's anywhere from 40 to 118. I don't have the specific numbers in front of me, but it's a minimum of 40% capacity up to 118, similar to the IQ Drive 23 SEER. And air handler speeds or gas furnace speeds will be 2 speeds. You'll have a low speed and a high speed. Again, Tim with All-American, is the 53,000 BTU rating on the 5-ton equal to C4? and how much does it increase the boost to C5? C4 would be nominal capacity. C5 would be the 118% capacity. Again, I don't have the details in front of me with the technical specifications, but refer back to your technical specifications for the exact numbers on that boost speed.
Lots of not lots of questions, I shouldn't put it that way, but definitely some questions in regards to the charging. And basically, stage 4, C4, if you will, that's your nominal capacity. That's 100%. So that's your opportunity for your stable, stasis, if you will, for adding or removing charge, getting your charge dialed in. In heat mode with heat pumps, I will always advocate weighing the charge in. Anyone out there in the viewing audience that has ever tried to charge a heat pump in heat mode under cold temperatures knows just how difficult that can be on the fly, so to speak, while the heat pump's running. So in cooling mode, stage 4, C4 will be your stable point. In heating mode, especially under colder temperatures, I will always advocate that the charge be weighed in. That's actually faster than trying to charge it on the fly.
Another question from Tim with Nolan. The wiring diagram in the II shows a suction line temperature sensor. Is this true or not? It is true. We do have a suction line temperature sensor that is located on the true suction line of the outdoor unit. It measures that temperature in the heating mode, again, to help also with determining when defrost is needed. Another question, Pedro with the Reference Center. Is the 18 SEER matched with a B6 air handler? If yes, which one? Yes, it is matched with the B6. I believe it's a B6 VMAX. Air handler would be the correct match with that. Again, verify with your technical specifications on the proper match. Refer back to the tech specs. Lee with Coburn's, are these going to replace the IQ Drive 22 SEER heat pumps? No, not at this point. It's just another product offering that we have for the field and for the dealers and for the consumers. The IQ Drive 22 SEER IQ Drive heat pump will still be available in the very near future. I've not heard of anything different. Jay with RE Michael is asking if there's a dedicated charge mode, and no, there's not. Essentially, when you input at the start of the cycle a Y1, Y2 input, the unit will always start at C4, run there for 45 minutes. You need to do your charging within that 45-minute period of time. If you need to still continue to charge the unit after that 45-minute period of time, you need to cycle down the unit, restart it back up in that C4, and continue adding charge from there. Again, keep those questions coming in.
Also, don't forget, in the event that you have dealers, if you have someone that was interested in wanting to be present for today's Lunch and Learn, but they just could not make it for whatever reason, these are always archived back onto NordINU.com. You can always sign up. It doesn't cost anything for NordINU. You can sign up and register yourself and then go back into the video archives and watch any of the previous video that we've done, including the Lunch and Learns today and in the past. So if you have anyone that's expressing frustration that they've missed something, that's not the case. The Lunch and Learns are always archived back to NordINU, including the question and answer session as well. So keep that in mind.
Another question from Bob with MB Handy. Can I use the Broad Ocean motor tester to test the condenser fan motor? No, you cannot on this. The fault handling is handled by the interface board on the outdoor unit. and that will determine if there is a motor issue with the broad ocean motor on the condenser fan motor. Again, if you have any other questions, please don't hesitate to ask them. John with Partner Supplies has a question. When the condenser ramps up to 118%, how does the indoor blower adjust itself? Again, that adjustment is only going to be made by Y1, Y2 input. If it goes up to that 118%, the motor will, the indoor blower motor will go up to high speed because there's a Y2 input on the thermostat. So that's how it will know if it's ramped up. Again, if you have any other questions, please submit them now. We'll keep going here for a few minutes more. If we don't get any other questions, we'll go ahead and end it for now. Looks like we have one more question from Mike with National Sales. Defrost work the same as the IQ drive, or is it timed?
Well, no, the defrost on the 18 SEER is controlled. It's the demand defrost. It more closely resembles what you would see in the 16 SEER product rather than like an exact carbon copy of what's done in the IQ heat pump. One of the things, though, that it does resemble in the 18 SEER as what you would find in the IQ heat pump is that it will basically ramp the unit down, pull it down into the lower stage, and then kick the reversing valve over and restart the compressor, giving it that really nice soft shift feature, so you don't just ram the reversing valve over to the other side and generate a lot of noise or any unnecessary wear and tear on the reversing valve. But it's actually the adaptive style of defrost, which is a little more closely resembled by the 16 SEER product than a step-for-step carbon copy of what you see in the IQ product line. It's not timed, I'll put it that way. It's not strictly just a timed feature, I guess. Maybe that was the better way to answer the question.
Yeah, it's our standard adaptive demand defrost cycle. It's similar to what we're using with the IQ drive. Kind of the same steps. You still go through the pre-defrost, then the defrost mode, and then determining the temperatures afterwards when we've got clear coil temperature stage on it. Question from Jim with Airco: when will consumer literature be available? Check online, see if it's available up there. I'm not too sure if it is. If it's not up there, check with our communications department or our literature department, see if they have any consumer literature available there. And again, if you have any other questions, please let us know, or please submit them by clicking on the left side of the screen. Mike is asking with National Sales, after a call for cooling on a 90-degree day, what step will the unit start on? Again, it's going to be based on the Y1, Y2 input. If you are restarting the cycle with a Y2, you're going to start at that C4. If you're only putting in a Y1, Y2 input, that's determined by the prior run cycle and length of time that it was, and it will determine which one of the first three stages that the unit will run at. That's all built into the software, and it's based on runtime and temperature outside. So I guess on a 90-degree day, if you only have a Y1 input, you're probably most likely going to go up to the stage 3 of cooling. Well, with that, we don't have any new questions. We'll wrap it up from here. Again, thanks for watching the Lunch and Learn on the 18 SEER. We have already done some pre-training with our TSAs at the TSA conference. There is training material available out there that can be ordered through our literature storefront. Again, the TSA can do the training, or we would be more than happy to send one of our fine trainers out to do training for distributors and dealers. If you have any other questions after we get off the air here, just shoot me an email at Priestley, DPRIESTLEY, D, @nordine.com, and I'll be happy to get an answer for you. Thanks.